Imagine it's the year 2037, the world has finally created the first functional teleporter. You step in the boat in America, and just a few seconds you appear on the other side of the world. Japan,
Naruto! Sasuke!
Russia, Singapore, or even another planet like Mars or Venus. Distance simple no longer matters. It would be a instant journey, painless, without motion sickness, and above all, without limits. But there is a small catch. The teleporter doesn't move your current body, and you are probably already thinking, wait, but if I went to a completely different place miles away, I went in my own body, right? And not exactly. But for you to understand this, you would have to understand how a teleportation machine really works. While it seems simple in the movies, and in reality it involves solving some extremely complex problem. And for that, we have two main options for teleportation: Star Trek versus quantum teleportation. The first option would be like in Star Trek. Imagine stepping the boat where you are completely scanned atom by atom. All the information about every particle in your body, your memories, and even your personality is encoded into a gigantic digital file. Then you would be disintegrated at the departure point, and this information would be sent to the destination, be it Japan, China, or maybe even Brazil, where identical machine uses locally available atoms to reconstruct a perfect copy of you. Not just your physical form, but also your memories, your thoughts, and even your heartbeat you had at the moment of departure. The second options would be with quantum physics, something much more tangible today, by the way. We could use the phenomenon called quantum entanglement. And here's a simple way to think about it. Imagine you have two magic coins that are linked. If you spin one coin and it shows head, you immediately know the other coin shows tails. Even if it's on the other side of the universe, distance no matter for them. They are permanently connected. In fact, China has already used this effect to teleport the state of a photon. Do you know, a particle of light from the ground to a satellite in space. But hold on, this doesn't mean the photon actually moved. What travel was the information about it, and the original particle was destroyed in the process. And this isn't a design choice, it's a law of physics. The no-cloning theorem says that to perfectly read the state of a particle and apply it to another, you inevitably destroy the original. This form to teleport is more like cut and paste than copy and paste. The very act of creating the copy destroys the original in the process. But here's the problem. That works for one particle. Now trying to do this with a human body, with its trillions of particles, would be like trying to move an entire library letter by letter from every single book, and still having to burn the original library in the process, by the way. Actually, it's even more complex than that. Basically, to save all the data from every single atom in one person, the file would be gigantic, measured in zettabytes, more than all the digital information generated by humanity in the entire year. And you'd have to do it instantly. Both ideas sound promising as a means of teleportation, the act of moving something instantly to another place. But both ideas share the same scary problem. The original body would have to disappear. Furthermore, what emerges on the other side might look like you, act like you, remember exactly you remember, but did your consciousness, you know, the state of knowing you are alive, actually travel through that machine? This discussion leads us directly to the famous paradox of Ship of Theseus. Imagine there's a grand old ship. In the first year, it suffered a collision, and some of its wooden planks needs to be replaced. In the second year, the mast breaks during a storm and is also replaced. And so year after year, small parts are renewed so the ship can continue its voyage. After 30 years, every single original piece has been replaced. Planks, sails, masts, every screw, and every nail. On top of that, the crew has completely changed. No one of the original sailors are still aboard. The question is it still the same ship? Now apply this to teleportation. If your body was taken apart and then rebuilt with brand new atoms, are you still you? Or would it be like the Ship of Theseus, a perfect replica that carries the form and functions but has lost its original essence? This raises some terrifying dilemmas. If a machine can recreate you perfectly with every every cell, every memory, every detail identical to the original. What about your consciousness? You know, the one that is watching this video right now. It probably wouldn't survive the transfer. The moment you stepped in the machine, you literally died. Even if another you goes on living, with all your memories, with the same desires and voice, it's not you who opened their eyes on the other side. It's just a fake continuation, a new plank in an old ship, a soul replaced by illusion of continuity. But there are far more. What if grotesque errors happen? It's what we call the fly scenario. What if the scanner isn't 100% perfect? And what if a single insect or a stray hair that isn't yours, or even just dust, gets in the both with you? The computer in code logic might try to integrate that information into your body during the reconstruction. Well, and now this thing is you. Or even worse, the data corruption scenario. Think about it. Your body has a zettabyte-sized file. What if during the transmission to Germany, a single stray cosmic rays alters one single bit of that file? An error from 0 to 1. You could arrive at your destination missing important memory like that you are married, or with a fatal flaw in your heart, or without your arm, for example. Every trip would be a game of quantum roulette, where the prize on the line is your own physical and mental integrity. And can be worse than that. If this were possible, ignoring the no cloning theorem, what would really happen? Imagine that, a little glitch in the machine, the original version of your body, you know, that one was scanned, is not disintegrated as you should be. Now there are the two identical versions of you, one who stayed behind and one who appeared on the other side of the world, but both with the same memories, the same emotions, both believing they are the real you. This idea is similar to the cop experiment. Imagine this. One day you are invited to a revolutionary experiment. You enter a white room where a scientist says, "I will create a perfect copy of you." Not just physical. Every cell, every memory, every thought will be replaced, like the teleportation scenario that we saw. You take a step, lights flashes, a metallic sound echoes, and suddenly right there beside you is you. The same face, the same clothes, same look of surprise on your face. The cop looks around, smiles, and says, "Wow, it's really weird seeing myself like this." And you think so too. Both of you have the same childhood, the same dreams, the same fears, but now you are two different people looking at each other. And then comes to the most uncomfortable question of all. If you one has to be erased, who is the real one? What if you are the copy and just don't know it? And if the copy continues living and you disappear, it feels like it's still you. This suggests that maybe our identity isn't just the sum of our parts. Maybe there's something that can be copied. Something that is lost the moment the body is undone. Neuroscience doesn't have a definitive answer. It knows that consciousness arises from the brain, that it's a product of electrical and chemical activity among billions of neurons. A study published in journal Science in 2023 identified a possible consciousness threshold related to specific patterns of activity in the frontal and parietal regions of the brain. But even with this breakthrough, science still doesn't understand exactly how this activity transforms into the subjective experience of being you. And this opens the door to some deeply disturbing questions. Is consciousness just a process, a continuous flow of information, just a chemical reaction inside your brain? By interrupting that flow, that for a millisecond, doesn't consciousness die? And if it dies, does it come back? Or is what comes after just a simulation that believes it's alive? Some neuroscientists believe that consciousness is deeply connected to the continuity of brain activity, like a live stream that must always be streaming. Imagine watching a live stream as long as the signal continues. Everything makes sense, but if the signal drops even for a second, what comes back might look the same, but no longer the same moment. In the same way, if your consciousness is interrupted even for an instant, there is no guarantee that the subjective experience of being you will continue from where it's left off. What might emerge next could be something entirely new, with the same information but a different spark, or no spark at all. This is the core of what philosopher David Chalmers calls the hard problem of consciousness. It's the idea that even if you could perfectly reconstruct a brain atom by atom, there is no way to prove the original subjective experience, the you, would actually be there. In the end, teleportation might actually work, but not in the way we think, because for you to arrive on the other side of the world, you might have to die on the way. So that's the final answer? Or are we doomed? Is teleportation inevitable, just a glorified suicide machine? Well, maybe not. Science fiction, which loves to present us with these dilemmas, has always true of the solution. There is a third way, another type of teleportation that completely avoids the problem, death and identity. It's teleportation via wormhole. Instead of scanning, destroying and rebuilding your body, this technology would bend the very fabric of space-time, creating a shortcut between two distance points, a Einstein-Rosen bridge. The main advantage, your original body, atom by atom, would travel through this tunnel in space. There would be no copy, no disintegration, and no digital file. The flow of your consciousness would never be interrupted. You would step in here and literally step out there. The you that arrives is the same you that's left. With this alternative, the discussion shifts. The problem is no longer teleportation itself, but rather the type of teleportation. And that changes everything, because sometimes the price of convenience is your own existence. Well guys, this is my first video on this channel. Thank you so much for watching all the way to the end. If you enjoy it, please consider subscribing and leaving the like. This will help me a lot. Thank you. See you.